Next video. In today's video I will show you how to make a raging wave using shaders in threejs. Now again, just to be clear, I don't understand shaders fully, so I won't be able to explain it much to you guys, but yeah, let's see how it goes. If you haven't watched my previous tutorial, go watch it. Like, I have already shown how to set up shaders with Next.js, and I'm using Next.js in my project. So yeah, and I have created a separate component for it. First of all, you can mark it as use client, which is a new way of doing client side rendering in Next.js. Next, I have just created a scene. Inside that, I have created a water geometry, and inside water material I have just added our vertex shader and fragment shader. And inside uniform I am passing this value from JavaScript side, all these values from JavaScript side, to our vertex shader. Then I have created our water, and I have set an rotation and added to our scene. The next stuff remains same as usual. Like, I have created size, I have created camera, orbit controls, then the renderer, then the resize and double click, and I have created a clock. And inside the tick function we are just animating the u time dot value to equal to elapsed time, then updating our controls as well as rendering our screen and doing request animation frame, as well as I have rendered an HTML canvas at the bottom. Now for the fragment shader, so this is kind of simple. So I have defined all the depth, color, surface color, color offset and color multiplier, and these we are getting from the vertex shader. And I have just mixed those strength, created a color for it and assigned it to our GL frag color. Next, I think this should be this. I think I might have missed that out. So here you can see, so this is the actual output. So yeah, so this is for the fragment shader. And for the vertex shader, we have defined all these values which we first get from the JavaScript side. Also, I have defined a shader material and not a raw shader material, which you can see over here. That's why we don't need to define all the values. Some of the values are already present inside when you use shader material, so you don't have to declare it again. And inside the vertex shader I am just fetching this, getting this all this from JavaScript side, and this will be passed to fragment shader over here. Next, this I have just copied from a classic Perlin 3D noise by Stefan Gustafsson. Sorry if I am pronouncing that right, but I have just copied this from GitHub. Yeah, so this will help us for the Perlin noise. Okay, so I will slowly scroll through it. You can just copy it from GitHub, just search for that name. And inside the main function, first we are defining our model position, and here there is some kind of a mathematical calculation which is beyond me. Then we are looping over our iterations. Don't keep these iterations too high on your JavaScript side, keep it a minimum. And here we are defining our elevation. Okay, so this is our elevation, and here we are setting our model position dot y equal to elevation. And here we are also defining our view position, projected position, and then assigning it to GL position. And here we are just passing the value from vertex shader to fragment shader, and this is the final output for it. So yeah, that's it. Thank you for watching. Bye.